Hey guys, welcome back to the channel. Today we will start our new topic that is called scale in engineering drawing, right? So let's start. A scale is a measuring instrument used to measure and draw accurate technical drawing. So using scale we can draw a straight line, isn't it? So actually what we are drawing, we are actually comparing our measurement with the standard length, isn't it? So scale is ultimately a comparator using which we can compare our length unit to the standard length. Here in this topic, scale is defined as a ratio of linear dimension of element of the object as represented in a drawing to the actual dimension of the same element of the object. So it is a ratio. For example, let's say this is my object. So length of this object is, let's say, a 30 millimeter. So if I want to draw this length on some drawing sheet, let's say I'm preparing the drawing. So this is my front view of this side, right? So if I draw the length of this side is equivalent to 30 millimeter. So according to this definition, scale is a length of drawing. So this is my drawing. So length of drawing divided by actual length of object. So in drawing I have drawn this length is equivalent to 30 millimeter. So 30 millimeter divided by actual length. Actual length is also 30 millimeter. So scale is equal to 1 by 1. It is also known as a full size scale, right? Similar way, if I prepare another drawing with the length is equivalent to 15 millimeter while the actual length is 30 millimeter, right? So scale would be 15 millimeter, that is the length of drawing. In drawing I have drawn 15 millimeter divided by 30 millimeter, that is actual length. So here in this case, scale would be 1 by 2. The scale in engineering drawing are a set of labels or numbers which are used in the particular system as a measuring or comparing parameter. So ultimately we are comparing our length with some standard parameter, right? With some standard length. It may not be always possible to prepare full size drawing, therefore it is drawn proportionally smaller or larger. So when drawing are drawn smaller than the actual size of the object, as in case of a building, bridge and large machine, the scale used is said to be reducing scale, because for preparing the drawing we are proportionally reduced dimension of the objects. So that's why it is called a reducing scale, and it is generally represented as a 1:5, where first number indicates the length of drawing divided by second number indicates actual length of object, right? Drawing of small machine parts, mathematical instrument, watches are made larger than their real size. They are said to be drawn on an enlarging scale. So we know a wristwatch component are very smaller, we cannot see using the naked eye. So to prepare a drawing of such a small objects, we have to proportionally increase the dimension of the object. So for that purpose the enlarging scale is used. So generally enlarging scale is represented as a 5:1. So first digit indicates the length of drawing is to second digit indicates the actual length of object. So x scale is equals to x:y. So where first digit indicates dimension of a drawing and second digit indicates actual dimension of object. So these are the various standard scale which is recommended by Bureau of Indian Standard, and which is defined in this SP 46 2003 revision. So reducing scale 1:y, these are the standard reducing scale 1:y. 1 millimeter on drawing is actual 2 millimeter of actual length. Similar way, 1 millimeter of a drawing which has a 5 millimeter actual length. So we are reducing that 5 millimeter actual length to 1 millimeter on our drawing. That's why it's called a reducing scale. Similar way, enlarging scale, 50 millimeter on drawing is equivalent to 1 millimeter of actual length. So we are proportionally enlarging the size of the component, right? So that's why this is called an enlarging scale. These are the standard scale that we can use for preparing our drawing. And this is my full size scale. If we draw the object having the same with the actual length of the object on the drawing, then it's called a full size scale. Intermediate scale can be used in exceptional cases where a recommended scale cannot be applied for a functional reason. We can even use the intermediate scale, for example 1:3, right? So depending on our functional requirement, we can prepare the scale. Now here is the standard size chart of the drawing sheet, right? Starting with this A0. So the surface area of this A0 drawing sheet is equivalent to 1 meter square. When we are moving from A0 to A5, the area is proportionally reduced by half, right? So here is a question for you. When we are moving from A5 to A0, which scale we are using? If you know the answer, comment in the comment section, and I will post the solution later on. So the dimension of a large object must be reduced to accommodate on a standard size of drawing sheet. So reducing scale, why we should use reducing scale? So because let's say this is the building, I want to draw the drawing of this building. So we cannot draw the drawing of this building on a standard drawing sheet, isn't it? So we have to proportionally reduce the size of to accommodate its dimension on a drawing sheet. So this reduction creates a scale of that reduction ratio. Such a scale is called reducing scale, and a ratio is called representative fraction, right? So if I want to make a drawing of this object on this drawing sheet, right? So I have to reduce proportionally each and every dimension so that the shape will not distort, and we can accommodate its drawing on our drawing sheet. Next is enlarging scale. So in case of tiny objects, dimension must be increased so that one can see details of the object clearly, like a component of a wristwatch are very small in size, therefore it is drawn using enlarging scale. So here is an example of wristwatch gear mechanism. So to make the drawing very clear, we have to proportionally enlarge the size of the component. So here we have to use enlarging scale. So these are some of the units that we are going to use. Be friendly with this unit. So 1 kilometer equal to 10 hectometer, 1 hectometer equal to 10 decameter, 1 decameter equal to 10 meter, 1 meter equal to 10 decimeter, 1 decimeter equal to 10 centimeter, 1 centimeter equal to 10 millimeter. This is the area of unit. 1 hectare equal to 10,000 meter square, and last two are the area unit of the volume. 1 liter is equals to 10 raised to minus 3 meter cube, and 1 gallon is equals to 231 inches cube. So you have to remember this unit conversion, because we are going to use this unit conversion while constructing the scale. Next is a full size scale. So it is drawn on the paper using actual size of component. Conversion table of unit is given. So 1 micron, that is equivalent to 10 raised to minus 6 meter. All this SI unit is already we have discussed. 1 kilometer equal to 1000 meter. Now let's say 1 yard. These are the FPS unit. 1 yard is equal to 3 feet, and 1 feet is equals to 12 inches. 1 mile is equals to 1609.34 meter, and 1 nautical mile is equals to 1852 meter. So these last 4 unit you must remember. the scale can be expressed in following three ways. So one of the ways, engineer's scale. So in this case, relationship between dimension on the drawing and actual dimension of the object is mentioned numerically in this style as 10 mm equal to 5 meter. So if we represent scale in this style, then it is called engineer's scale, right? Another way to represent the scale is a graphical scale. The scale is drawn on the drawing itself. As the drawing becomes old, engineer's scale may shrink and may not give accurate result. However, such is not the case with the graphical scale, because if the drawing shrinks, scale will also shrink, and hence the graphical scale is commonly used in a survey map. So in this chapter we are going to learn this, how to construct a graphical scale. And third way is a representative fraction. So it is a ratio of length of object represented on drawing to the actual length of object represented is called a representative fraction. So RF is equals to length of drawing divided by actual length of object. If we are dealing with the area, then RF becomes a square root of area on drawing divided by actual area of object. And if we are dealing with the volume, then RF is equals to cube root of volume on drawing divided by actual volume of object. You have to remember this formula. For calculating RF, both the length should have same unit. All the dimension of the object should be drawn to the same RF. So while preparing the drawing, all the length unit of the object should be prepared with the same RF, right? Scale and RF are synonymous, as a scale is formatted as X is to Y, while RF is denoted as a X by Y. In title block, scale should be shown as a scale X is to Y. If a different object are drawn to the different scale on this sheet, then respective scale is mentioned below the drawing of that object. So these two formula are important for this subject point of view. RF is equals to length of drawing divided by actual length of object, and the length of graphical scale is given by RF into maximum distance to be measured using that graphical scale. Now let's find out what is RF in this case. If a 5 cm long line in the drawing represents 3 km length of the road, then in engineer's scale it is written as 1 cm equal to 600 meter, right? But in graphical scale it is denoted by RF is equals to, we know already the formula, length of drawing. RF is equals to length of drawing. So length of drawing is 5 cm. 5 cm long line in the drawing. So length of drawing is 5 cm divided by actual length of object. So that is 3 km. So 5 cm divided by 3 km. We have to make this both the unit same. So let's convert kilometer into centimeter. 5 cm divided by this first kilometer to meter, multiply by 1000, again meter to centimeter, multiply by 100. So we can get our RF is equals to 1 by 60,000. I hope you understand how I have calculated the RF. Similar way, let's say if a gear with a 15 cm diameter in the drawing represent an actual gear of 6 mm diameter, in a graphical scale it is represented by again RF. Length of drawing, what is the length of drawing over here? So length of drawing is a 15 cm, while the actual length of object is a 6 mm diameter, right? So 15 cm divided by 6 mm. So I have converted over centimeter into millimeter. 15 cm equal to 150 mm. So ultimately I will get RF is equals to 25 by 1, right? Types of graphical scale. So these are the types of graphical scale. So first one is a plane scale, generally used for dimension up to a single decimal to represent a dimension up to a single decimal places. Diagonal scale for dimension up to 2 decimal places. Then vernier scale for dimension up to again 2 decimal places. Comparative scale for comparing two different units. Scale of chords for measuring and construction of angle, and isometric scale for preparing the isometric projection. So these are the various types of graphical scale. We are going to learn plane scale, diagonal scale and vernier scale in upcoming videos. I hope you understand the concept. If you do so, do like, share and subscribe to my channel for such a more content, and we'll see you in the next video.